Welcome to this deep dive. Today, we're tackling wood preservation, really essential knowledge.
Definitely.
We'll be using the Wood Preservation and Wood Products Treatment Training Manual as our guide, sort of section by section.
So think of it as a key reference, especially for continuing education.
Right. And our mission, really, is to make sure you walk away understanding how to protect wood.
And why it matters so much.
Yeah, especially for wood that's, outside, facing the weather, or even in the ground.
Exactly. And understanding these basics, it gives you a really solid foundation for making good decisions about wood.
Yeah.
Ensuring it lasts, keeping things safe.
And we'll use some analogies along the way, try to make the technical stuff a bit more relatable.
Sounds good. Should connect it to the real world.
Okay, let's start with the first part of the manual, properties of wood.
The fundamentals.
It kicks off with the structure, right? Sapwood versus heartwood.
Yeah. Think of the sapwood, that lighter bit on the outside, as the tree's plumbing system when it's alive.
Actively moving water and nutrients around.
Exactly.
Yeah.
While the heartwood, the darker core inside, that's more like the structural support. It's often naturally tougher against decay.
So active plumbing versus strong inner core makes sense.
Mm-hmm.
Then the manual gets into what wood's actually made of. Cellulose and lignin are the main players.
Right. Cellulose is basically a complex sugar. And here's the key thing.
That's the food source.
That's the food source for a lot of things that damage wood, like carbs for us, but for fungi and insects.
Okay. And lignin.
Lignin provides the rigidity, the stiffness. It's like the wood skeleton.
So food source and skeleton. Understanding that helps explain why wood gets attacked and, well, how the preservation stuff works, I guess.
Precisely. It sets the stage for understanding the threats.
Which brings us nicely to the next section, wood-damaging pests. The manual groups them into fungi, insects, and marine borers.
The main enemies of wood, you could say.
Let's tackle fungi first. Wood-inhabiting fungi. What do they need to thrive?
Well, the manual lays it out like a recipe. They need enough oxygen, they need moisture, and this is critical, generally above 30% moisture content.
30%, okay.
A decent temperature, somewhere between, say, 41 and 104 Fahrenheit usually works for them.
Wow, quite a range.
And, of course, the wood itself as food.
So take away one of those ingredients.
And you disrupt their growth, yeah.
The manual makes a distinction, too, between fungi that actually destroy the wood's structure.
Yeah, the decay fungi. Those are the ones that cause structural problems.
And the ones that just stain it, like mold or sap stain, affecting the look mostly.
That's a really important difference. Decay fungi are like weakening the foundations. Staining fungi are more like cosmetic issues, though mold can sometimes lead to other problems.
Right. So focusing on the destructive ones, the decay fungi, 3 main types mentioned.
Yes, brown rot, white rot, and soft rot.
Brown rot, what's its signature?
Brown rot mostly goes after the cellulose. It leaves behind the lignin, which is brownish. The analogy used is like eating the soft parts of something, leaving just a brittle frame. So you look for that brown color, shrinkage, cracks across the grain.
Cross-grain cracking, okay.
And when it's dry, it can get really powdery.
Got it. And white rot.
White rot is, let's say, more thorough. It attacks both the lignin and the cellulose.
So it breaks down more of the wood structure?
Right. And it often leaves the wood looking kind of bleached or whitish, a more complete demolition, if you like.
Okay. And the third one, soft rot.
Soft rot tends to happen in wood that's really water saturated, like constantly wet. It causes a slow softening of the outer surface.
Like wood soaking in water for ages, the outside gets weak.
Exactly that.
So those are the decay types. What about the staining ones again, sap stain and mold?
Right. Sap stain discolors the sapwood, often goes quite deep. You usually can't just brush it off, like a deep fabric stain.
Mm-hmm. And mold?
Mold is that fuzzy or powdery stuff on the surface, mostly an appearance issue, but the manual points out it can help the wood absorb more moisture.
Which could then encourage decay fungi later on.
Potentially, yeah. So the best fix for mold is always to get rid of the moisture source.
Good point. The manual also mentions chemical stains briefly, just to differentiate, like iron reacting with tannins.
Yeah, that's not biological. More like rust forming. Creates a black stain sometimes.
Okay, so that's fungi covered. What about insects? The manual lists termites, carpenter ants, and beetles.
The 6-legged crew.
Yeah.
Yeah. Termites are obviously a big one.
Especially subterranean termites, right? Living in the soil.
In many areas, yes. They build those mud tubes for protection as they travel from the soil up to the wood, like little highways.
And then there are damp wood termites, too.
Correct. They live in damp wood and get their moisture directly from it. They tend to be larger, especially the soldiers with those big heads.
Okay. How are carpenter ants different?
Big difference. Carpenter ants don't actually eat the wood.
Oh, right. They just excavate it.
Exactly. They chew out galleries to make nests, like tiny miners. Key signs are their elbowed antenna, that pinched waist, and they kick out wood particles. Looks like sawdust. It's called frass.
Frass. Got it. And beetles. Several types mentioned.
Yeah, powder post beetles, for example. Their larvae tunnel through hardwoods and softwoods, leaving this fine powder behind.
Like little trails of dust.
Anobid beetles often go for damp softwood in, say, crawl spaces. They leave little round exit holes when the adults emerge.
Like pinpricks in old furniture.
Kind of, yeah.
Yeah.
And then you have round-head and flat-headed borers, but they mostly infest standing trees or freshly cut logs. They don't usually reinfest seasoned wood in buildings.
It's more a forest issue then.
Generally, yes.
Okay, the last pest category. Marine borers.
The underwater threats. If you have wood in salt or brackish water, these are the problem. The termites of the sea, basically.
Main types.
Shipworms, which are actually mollusks, like clams they drill inside the wood. Hard to detect from the outside.
Like a hidden infestation.
Exactly. And then gribbles, which are crustaceans. They nibble away at the surface, causing erosion over time.
Like constant surface grazing.
Pretty much.
Okay, so we know the enemies. Now, how do we fight back? The manual outlines control strategies.
3 main lines of defense. Moisture control, using naturally resistant wood, and chemical treatments.
Moisture control seems like the first logical step.
Absolutely. It's often the most effective non-chemical approach. Remember, fungi need over, say, 30% moisture.
Right.
And dry wood, generally below 19% or so, is much safer from both decay and many insects. So, drying the wood is key.
Cutting off their water supply?
Essentially, yes. The manual mentions ways to store logs, like keeping them submerged or sprayed, which limits oxygen too.
But for lumber we use?
Seasoning or drying is crucial. Air drying or kiln drying. Kiln drying is faster, more controlled.
Like precise cooking versus just leaving it out. Gets it ready for use, prevents stain, decay, insects, reduces weight, increases strength.
All those benefits.
Yeah.
And it prepares the wood properly if you are going to apply chemical treatments.
And it's not just the wood itself, it's the building design too, right?
Huge factor. Good drainage, gutters, roof overhangs, keeping wood off the ground, designing the structure to stay dry.
Like giving the house a good raincoat and boots.
Good analogy, yeah.
What about using naturally resistant wood?
That's the second strategy. The heartwood of some species, like certain cedars or redwood, has natural chemicals that resist decay and insects.
A built-in defense system?
Sort of, yeah.
Yeah.
But importantly, the sapwood of almost all species isn't resistant. And even resistant heartwood isn't totally immune, especially in ground contact.
And they tend to be pricier.
Usually, yes. Often used for things like decks or siding, where appearance and some durability are valued.
Okay. So that leaves chemical control.
The third line of defense.
Here.
And the manual stresses, any preservative used must be registered by the EPA.
Meaning it's been checked for effectiveness and safety within limits.
Right. And how well it works depends on a lot of things. The specific chemical, how it's applied. The wood species sapwood treats much easier than heartwood, generally. The wood's moisture content, when treated, how much preservative gets in and stays in, that's retention and penetration.
Like getting the right dose of medicine delivered properly.
Exactly. And for tough conditions, like wood in the ground, pressure treatment is usually needed to force the chemical deep inside.
The manual divides the chemicals into general use and restricted use.
Correct. General use ones like copper naphthenate are available over the counter, so to speak. Restricted use pesticides require training and licensing because they pose higher risks.
What are the main restricted use ones?
Historically, the big 3 were creosote, pentachlorophenol, or penta, and inorganic arsenicals like CCA.
Creosote. That oily stuff for railroad ties, poles.
That's the one. Very heavy-duty, oily preservative from coal tar.
And antada.
Pentachlorophenol, usually dissolved in oil, also used for poles, posts, timbers. Lots of restrictions now, especially around homes.
And the arsenicals like CCA, copper chromated arsenic.
Right. Very effective. The copper fights fungi. The arsenic fights insects. But arsenic raised health concerns, so residential use was phased out. Still used in some industrial or marine applications.
So lots of regulations around those.
Definitely. And the manual mentions newer alternatives too, like alkaline copper compounds, which avoid chromium and arsenic.
Which brings us to maybe the most critical part, protecting people.
Absolutely paramount. These chemicals are effective because they're toxic to pests, so handling them safely is non-negotiable.
The manual talks about acute versus chronic toxicity.
Yeah, acute is the immediate effect from one exposure. Chronic is the potential harm from repeated, lower-level exposure over time. The restricted use classification often relates to chronic concerns.
And the absolute key sources of information are
The EPA-approved product label, that's a legal document you must follow, and the Material Safety Data Sheet, or MSDS.
right. Who's most at risk during application?
The applicators themselves, obviously. Mixing chemicals, handling the treated wood right after treatment, entering the treatment cylinders, spraying, cleaning up. Lots of potential exposure points.
How do these things get into the body?
Skin contact is a major route dermal absorption. Eyes too. Also inhalation, breathing in vapors or dust. Mouth is less likely but possible.
And skin absorption isn't the same everywhere on the body.
No, some areas absorb more readily, and solvents in the preservative can increase skin penetration.
So protection is key. What does the manual recommend?
First, the employer's responsibility. Proper procedures, providing the right protective gear. Then, personal hygiene. Wash hands often. No eating, drinking, smoking in the work area. Launder work clothes separately. Basic safety sense.
And specific gear.
Always follow the label, but generally impermeable gloves are crucial. Leather gloves are a no-no, they can soak up the chemical.
Good point.
For tasks like entering equipment, you need full gear. Coveralls, jacket, boots, gloves, and a properly fitted approved respirator. MSHA or NIO approved.
Fit testing is important for respirators too.
Absolutely. A bad fit means it's not protecting you.
The manual also mentions a voluntary consumer awareness program.
Yes, an industry effort. The main tool is the Consumer Information Sheet, or CIS, for each restricted use chemical. You should get one when you buy wood treated with those.
And these CIS sheets have specific precautions.
They do. For arsenical-treated wood, for example, it stresses. Don't use it for cutting boards or countertops. Avoid food feed contact. Clean up sawdust. Dispose of properly. No burning wash hands thoroughly after handling.
Similar things for creosote and penta.
Yes, similar themes. Avoid prolonged skin contact unless it's sealed. Big restrictions on indoor residential use. No food contact. Proper disposal. No burning. Wear protective gear when cutting. Wash up afterwards. Specific details vary slightly, like penta not being for log homes.
So read the CIS for the specific product.
Always.
Okay, that covers human safety. What about protecting the environment?
Equally important, careless use or disposal harms wildlife, water, soil. These chemicals are toxic to more than just wood pests.
Runoff seems like a major concern.
Huge. Runoff from treatment sites or even treated wood can pollute streams, lakes. Penta, creosote, arsenicals, they're all highly toxic to fish and aquatic life, even in tiny amounts.
The manual talks about how long they might last in the environment.
Yeah, it discusses persistence. Penta can stick around in water and soil. Arsenic tends to bind to soil, but is still a concern. Creosote components vary. Some break down faster than others, but PAHs are a focus.
PAH.
Polycyclic aromatic hydrocarbons. Some are carcinogenic.
And groundwater contamination.
Also a serious risk mentioned. Not just from big spills, but potentially from soil contamination near treatment sites, improper disposal, even drips. And cleaning up groundwater is incredibly difficult and expensive.
So what are treatment plants doing about waste?
Many have systems to contain and manage waste. Closed-loop systems to recover and reuse chemicals. Proper drainage, drip pads, sumps to catch spills. Covering areas to reduce rainwater runoff, stormwater monitoring.
And storing the chemicals in containers safely.
Critical. Locked, dry, ventilated areas. Sealed containers. Protection against tanks rupturing. Rinsing containers properly before disposal at approved landfills. Following all the label and MSDS rules.
What about spills?
Need a plan. Personnel need training, know the chemicals, know who to call. A spill response plan is essential.
The manual also has a glossary, right?
Yes, very handy for defining all the technical terms we've been using. Brown rot, cellulose, heartwood, preservative, all that.
And a section for more information if people want to dig deeper.
Yep, list publications for further reading on pesticides, wood preservation standards, etc.
Finally, first aid. Always important.
Crucial. The manual stresses that the specific first aid info is on the product label, and MSDS, that's your primary source.
But it gives general guidelines.
Yes. For skin contact, wash well with soap and water. Eyes, flush with water for 15 minutes, see a doctor. Inhalation, fresh air, artificial respiration if needed, get medical help fast. Ingestion, immediate medical attention, specific advice varies by chemical, like whether to induce vomiting. Never induce vomiting if someone's unconscious.
Good reminders. Acute symptoms usually show up quickly.
Generally, yes.
Huh.
And prompt first aid makes a big difference.
Okay, so wrapping up this deep dive, wood preservation is, well, it's complex.
It really is. You need to understand the wood itself, the threats, fungi, insects, marine borers, the control methods.
And crucially, how to use these methods, especially chemicals, safely for people and the environment.
This manual provides that comprehensive overview. It's a vital resource.
Absolutely. And hopefully for you listening, this gives you that solid understanding needed for making good choices about wood, ensuring it lasts and is used responsibly. The analogies hopefully help connect the dots.
Yeah, bridging the technical to the practical.
So here's a final thought to leave you with. We see constant evolution in materials science and environmental regulations. Thinking about wood preservation, what new challenges or maybe new solutions do you see on the horizon for protecting wood sustainably in the future?
That's a great question. Balancing effectiveness, cost, safety, and environmental impact. It's an ongoing challenge and driver for innovation in this field, something definitely worth thinking about.